everyone. We have come to the last session of the first day. We have with us today Professor Sarit Kumar Das, and his topic, which is already there on the screen, is PhD and research. Are they synonymous? So it's a wonderful question for all of us to think about on this evening. So Professor Sarit Kumar Das is the Institute Professor at IIT Madras. He's also the former director of the Indian Institute of Technology, Ropar. Dr. S.K. Das, an Institute Chair Professor at the Mechanical Engineering Department, has more than 22,000 research citations. He has also guided over 40 PhD students and has published 4 books. The recent book got published now, the 5th book, and over 350 research papers. He's also the recipient of the IIT Madras' Lifetime Achievement Research Award, where he was formerly the Dean of Academic Research before moving to IIT Ropar. He was also a member of several policy-making bodies in Punjab and the other union governments. He's a recipient of the German Academic Exchange Service and Alexander von Humboldt Fellowships. He's a fellow at the Indian National Academy of Engineering and the National Academy of Sciences. He has also been awarded the Peabody Visiting Professorship at Mechanical Engineering Department, Massachusetts Institute of Technology, Cambridge, USA in 2011. He is the editor-in-chief of the International Journal of Micro-Nanoscale Transport and an associate editor of the journal Heat Transfer Engineering. His current research interests include heat transfer in nanofluids, microfluidics, biological heat transfer, nanoparticle-mediated drug delivery in cancer cells, heat exchangers, boiling in mini microchannels, fuel cells, jet instabilities, heat transfer in porous media, and computational fluid mechanics. And most importantly, Sir is also the external committee member of the Research Board of Anna University, and in the recent Research Board meeting, Sir has contributed significantly in framing certain changes for all the PhD scholars. So I welcome you, Sir, to Anna University, and we are very glad to have you this evening. May I request our director, madam, to please felicitate Sir.
So, from the topic, what you can see is I'm throwing a question to all of you, which is research and a PhD degree, they are synonymous? See, we study from our primary school to secondary school to colleges, then post-graduation, and the PhD is the highest degree anywhere in the world anybody gives. And so, we also know that the PhD is a research degree. So, research and PhD are synonymous, almost the same. Can we say that? That's the question. Now, why did I ask this question? Because this will tell you what for the next 3, 4, 5 years, or maybe 6 years, you are going to do. What are the pitfalls? What are the things that you have to keep in mind while doing research? And that's why I'm throwing this question, whether PhD degree and research, they are synonymous or not. Now, the most important thing is this difference. PhD degree is where you learn how to do research. How I differentiate this? A driving school in which you go to learn how to drive car, right? And then what do you get? After driving, you give an examination, and what do you get? You get a license, right? PhD degree is a license. Now, after getting the license, you can become Chennai auto driver, very notorious, or you can become Michael Schumacher, running the Formula 1, or become one of the top car sports persons. Now, what you will become, that depends on after getting the license what you do. License is just to tell that you can drive, nothing more than that. That's why I often tell to my students, the day you get PhD, you are the wisest and the most stupid person. Both at the same time. Why you are wise? You are wise because you have got the highest degree. Naturally, without being wise, university won't give you. And why you are most stupid? You think that you have learned research. It's not. Actually, today, at the age of 58, 59 years, I'm still learning how to do research. Because there are so many things which I don't know, which I try to do, and I learn. And so, PhD is at best the beginning of that learning, nothing more than that. So be humble. The research, whether it is experiment, modeling, your aim is to reveal the truth. Actually, research is not for getting publication, getting jobs, getting honors. You know, my biodata has been read, so many, honors, these, that. You don't do research for that. When you sit down with a problem, you don't think that by solving this problem, what honor you will get, how many publications you will get, what citations you will get. A Nobel laureate never does research for getting Nobel Prize. He does research, he or she does research and incidentally gets Nobel Prize. So all other things which come are incidental. So basic reason why people do research is you want to know. You want to know nature. You want to build new things. You want to make people's, society's life better. That's why you do research. You don't do research for getting job, for getting award, for getting publications. So that is the basic difference between research. PhD degree is to learn how to do research, and research itself is to find out the truth. This is the basic difference, and how one converts into another. This will be the topic of my lecture. But both of these requires one thing, which is an analytical mind and faith in scientific method, and not to compromise with that. Now these 2 points are very, very important. You need an analytical mind. What does it mean? You should keep on thinking about research, analyze it. It's not some procedure. See, one of the problems is this. Many students come and ask me, sir, if I register under you, can I get a PhD degree in 4 years? I said, yes, you can. But you can also get in 7 years. There are people who submitted in 12 years also. And there are people who have submitted in 3 years also. Now, it's not because the difference in time, difference in standard that they have done, it's not because that somebody was very clever, somebody was very intelligent and the other was not. No, it's not like that. Sometimes it is simply luck. Because this is the difference between any degree that you have done so far and research. In all other degrees, there are 2 differences. You have done B.Tech, you have done M.Tech, you have done schooling. What is the basic difference between those degrees and this degree? The first difference is, in all other cases, somebody else decides what you have to do to get your degree. Somebody makes a curriculum. Suppose to pass B.Tech, you have to get so many credits. Out of that, that should be your departmental, that should be non-departmental, these, that. Somebody makes it. Then somebody else teaches it. The person who makes the curriculum, he doesn't make the syllabus. Somebody else makes the syllabus, because no one is expert in all those subjects. So a person who is better in organic chemistry will make organic chemistry syllabus. The other one who is physical chemist, he will make a physical chemistry syllabus. So somebody makes curriculum, somebody else makes syllabus. Somebody else teaches it. And maybe same person or some other person evaluates it. And somebody else gives degree. And you are absolutely different from all of them. PhD is not like that. You decide what you have to do. So you decide your curriculum, you decide your syllabus, scope. How much would you like to do? Would you like to do an experimental work, theoretical work, a mixture of that, a completely different conceptual, survey-based work? What would you like to do? Nobody else decides. It's between you and your guide. Only you two decide. And how to do it, which method you will take, that is also not told by them. In chemistry lab, somebody will say, make a dry test, make a wet test. Here, nobody will tell what test. You have to decide. So the first difference is, you define this degree. Nobody else defines this degree. That's the first thing. Second thing is that you do not know the outcome. And that's why I said somebody takes 3 years to do PhD, somebody takes 10 years to do PhD, because when I choose a problem, I don't know it's a good, difficult problem or simple problem. It happened with me at IIT across the street. I defined a problem for a student. The student did 1/3 of it, and the doctoral committee said, this is good enough for a PhD. I gave the rest to the next person. He did another 1/3 of it, and the doctoral committee said, this is good for a PhD. So what I thought to be one PhD essentially became 3 PhDs. It can happen because it only in course of time you come to know what it is. So at the beginning you do not know. So this is another problem. So there is uncertainty. In fact, all of you who are entering research today, 4 years from now, there will be one question all of you will hate. You know what is that question? And people will be asking that question. And you will hate that question. When are you going to complete your PhD? This is a question your father will ask, your mother will ask, your friends will ask, your girlfriend, boyfriend will ask. And the thing is, you don't have an answer to that because you don't know. Sometimes I can tell you one case in which a student to set up the experiment took 3 years. 3 years for setting up the experiment. And he said, sir, I have to leave PhD. It will take infinite time. And what happened? Within next 6 months, his PhD was over. He went for a postdoc, and today he is a professor, he is a faculty member at IIT Madras. This is what can happen. So, there is no rule. Linear interpolation is a very bad theory for doing research. You cannot interpolate from the past what is going to happen in future. And that's why it has got its bit of uncertainties, but two things in both of them are very, very important. Throughout this, you must have whatever is happening, because every time good things won't happen, bad things will happen in research. You have to keep the analytical mind. Even if it is negative, you have to see, why did it happen? What is the reason it happened? And that's why analytical mind. And the second thing, you must have faith in scientific method. Not faith in supernatural power. That you may have. I don't discard that one. That's your personal belief. But as far as your research work is concerned, your faith should be in scientific method. There must be a scientific method to solve the problem, right? If one method fails, experimental method fails, maybe theoretical. If theoretical fails, maybe numerical. If numerical fails, you may come back to experiment once again. So this is very, very important. The next, besides getting you publication, degree, job, as I said, apart from these, what does research give you? Research gives you certain things. Skill of planning. See, master degree doesn't make you plan, because if you are given 5 subjects, you have to pass 5 subjects. But in research, it's up to you what you want to do first. So you need to do planning. Secondly, it helps you. What is the value of hope? Research is something which is not going to, the success is not going to come every day. I'll tell you, I did research, and my wife is a witness to that. I did research when I was teaching in NIT, Rourkela. That time it was called REC, Regional Engineering College. So the whole day I will teach, and evening I will sit down for doing my research. In the computer center first, then I will come back home, I will start doing it, and maybe night 12 o'clock, 1 o'clock, I will go for sleep. And after going to bed, suddenly something strikes me, and I get up and I sit down and start doing. And at 2 o'clock at night, I discover that that method has also failed. And so, you go down, go back, next morning you have to take 3 classes, 3 lectures you have to give. Now this is how I started my career in research. And that's why I'm saying that even after this, if you are frustrated at that, you are not for research. You have to give hope and patience. These are very, very important in research. The next thing is the art of management. You are not to manage only yourself. See, your experimental setup, some technician will work. You need some help. Some fabricator will come. He will give you. He will never give in time. He will say, sir, tomorrow. And then after 3 days, he will give it. When you check it, you find everything is wrong. You go back to him. So, you have to manage all these people, including you have to manage your guide also. Please understand, do not consider your guide to be a god. He is also a human being, he or she. Please understand, he also has got problems at home, maybe. He also has got his professional problems. He might have financial problems. So don't expect that he is, a God-given person who is sitting the solution for you. And whenever you go, he or she will offer a solution, and he will do, and you will quickly get the result. No. He will have. What is the difference between you and guide? After a couple of years, you will only become guide. So the difference is he or she might have little more experience. You do not know what to do, he or she will tell, try these methods. He or she may be able to tell you these 3 methods are there, you can try. But maybe your problem, none of these methods can solve. So please do not consider your guide as a friend, philosopher, and guide. Make him a friend. If he is a philosopher, very good. If he is not, don't worry about that. And of course, he is your guide. And the thing is, you must have a broad outlook. You are given a problem and you are just trying to solve. Yes, focus is required. But sometimes you are trying to solve something else comes out, which is equally important, equally interesting, maybe more interesting. So you have to keep towards that, and ultimately, after doing research for probably last 40 years or so, 35, 38 years, I'll tell you that people may tell getting a position, getting an award, getting a publication is exciting. But nothing is more exciting than getting the truth. When you solve a problem, when you see that, oh, this is what, nobody thought about that, and I am the person who brought it out in front of the world. That pleasure, you don't know it. When you do it, only then you come to know. See, the famous physicist Richard Feynman once told, he got Nobel Prize, so somebody said, how do you feel about getting Nobel Prize? He said, no, nothing much. Then nothing much? You got Nobel Prize, you don't feel anything? I said, yeah, because the excitement of invention, I got it that time only when I invented, and others have used it I feel happy about that. Now, whether Swedish Academy tells it or not, how does it matter? Now, Feynman is, of course, a completely different kind of a person. I would tell that, every researcher should read one book. Have you read? Surely you are joking, Mr. Feynman. Anybody read this book? Please read this book. It's, from first page to last page, you will laugh. It's Professor Feynman, who is known to be one of the greatest researchers of 20th century. His life story, but he has written in a very, very funny way. You read it, and you will find out that how the passion for research drives yourself. It is that passion, it is that pleasure of getting the truth, which is more important. Once you start doing, you will see that all the other things for which you admitted to Anna University will become less important. You will get that pleasure, and you will see that those have started coming without telling you. And that's what is very, very important. Now, there is a question. Many asks me, can you teach research methodology by giving a lecture? I mean, just like I'm giving. I'm telling this is research, that is research. By that, can you do it? Of course, if you have to cook a recipe, you have to cook it. But still, people see cooking shows. Why? They go to cooking classes. Why? Because that gives you at least certain ideas. You may use it, you may throw it out. But it is like, one player, Virendra Sehwag. He never used any kind of a standard coaching. He played his own way. But that doesn't mean there is no need for any cricket coaching class. So coaching classes are required. But after that, after taking the coaching, you do it your own way. You listen to Dr. Das, you listen to, next 3 days, lots of people. Keep them in mind. Maybe something will come to your use at some point of time. Take it that way. Don't take it too seriously. So, it cannot be taught because these are arts and experiences. You cannot teach art, you cannot teach experience. And they are diverse. Everyone's research, my experience will not match with the person who sits next to me. And hence, you cannot teach it. But there is a counter argument. Even art has a grammar. Even there are art schools, right? There are commonalities. Although research experiences may be diverse, certain experiences are common. And then it serves as a guidance to the research scholar. That's it. It's a guidance. Whether to take it or not, it's up to you. Now this is, Professor V. Ganeshan was one of the very great researchers and our dean also. He has passed away just last month. He has got a book on internal combustion engine. When I used to enter his room, he put certain jokes about research. And I would like to tell them. Actually, these jokes tell you what you should not do. First one, when you do not know what you are doing, do it very neatly. The first joke. Doing neatly is fine. But if a person is very neat, very particular, very punctual, probably he is not a good research scholar. I remember when I was in Germany, one day, one scholar, I was doing postdoc. So the Professor Roetzel, very reputed professor, to whom one of his scholars came. And he said, sir, in German, he said, sir, I want to go to America, so give me a recommendation. So professor said, I don't have very good idea about you, so don't take recommendation from me. He said, no, sir, if you are my doctor father. In Germany, guide is called doctor father. So you are my doctor father. If you don't give me, who will give me? So Professor Roetzel said, okay, come after 2 days. 2 days later, Professor Roetzel wrote a recommendation, and gave it to me. Professor Das, can you check whether everything is fine? Because he's going to America, so it has to be written in English. So German professors are usually, they are English, they write it like German language. So that's why they said there is anything mistake or not. So I read it. I said, fine. I said, this is a recommendation you could have given day before yesterday. Why did you wait for 2 days? He said, no, you have not read it properly. What I had to tell, I have written it there perfectly. You know what? He said, I have written, he is a very punctual fellow. He comes in time and goes in time. The comes in time is fine, but a researcher who goes in time is not a researcher. Because then you are not looking at your experiment, you are looking at watch. So this is the first thing. I said, fine. What else? He said, I have written, he is very obedient, he does whatever is told to him. Now whatever is told to him, if that is done, that is a schoolboy. That's not a researcher. Researcher has to do it on his own. So whatever I had to say, I have told it. Only the person reading it has to read it properly. So that's what I'm trying to say, that being neat, if somebody is very, very neat, I doubt. Because then he's spending time on that, not on research. The other one, the teamwork is essential. It always allows you to blame someone else. You are in a team, you say, no, this is not because of me, this is because of him. The other joke is, if reproducibility is a problem, conduct the test only once. Then there is no problem. I will come to reproducibility once again. If a straight line fit is needed, then you have only 2 points. Because between 2 points always you can draw a straight line, right? And if an experiment works, there is something wrong. Because experiment, this doesn't work, that doesn't work. If it works, maybe something really wrong. And if enough data is collected, anything may be proven by a statistical method. So these are something people try to do. Actually, Professor Ganeshan, that's the reason why he wrote it, that don't try to do this. The other one is, what is important in research? The method is not more important than the problem unless you are developing the method itself. What does it mean? You are trying to solve a problem. Please understand, the method by which you are solving is not important than the problem. See, I will give you an example. Somebody is doing computation. I am using finite element method. Some people, get into finite element becomes the more important point. Are you developing finite element method? Then it's a different story. If you are developing the method itself, but that's a very difficult problem. Because the methods are being developed by great people. At Ph.D. level, hardly anybody develops a method. And so, the method, somebody says, I am using spectroscopy. I am becoming obsessed towards spectroscopy. What is that? Spectroscopy is, it's a method. It's a equipment. You have to learn how to do it and how to use it. Oh, electron microscopy. I am becoming an expert. Electron microscopy, you become an expert, you become a technician. You are a researcher. Please understand. Methods you have to learn, but don't get obsessed by the method itself. Unless you are developing. If you do, research on electron microscopy, then it's a different story. If you do NMR, that's your method, research topic, okay. You spend time on that. Always look for novelty in research. Now, this is the most important thing. You will always say, what is new in that? Yes, research means novelty. No. There is this delta improvement research. You read this literature, and then you say, oh no, these parameters have been studied, so I will study one more parameter. Well, probably you will get a PhD by that. But you will lose everything. You won't get the excitement of discovering thing. You won't do anything which will allow you to do something in future. And hence, please do not do. Quite often, and now I am saying something which will create problem for madam and probably problem for Professor Velraj also, that please do not allow your guide to define your problem. Do not allow him or her to develop. If your guide says, okay, this is there, you work on this. You please tell that, sir, I will come back And I will see. You go back, you study literature, and you come back and have the courage to say, I don't think this is very important problem, sir. I will do rather something else. Have the courage to do that. Because unless and until you do that, see, your guide has got so many constraints. At the beginning, he or she has not judged you, your capabilities. So probably being a little sympathetic, he or she wants to give you a ready-made problem. Don't take a ready-made problem. Because if you take a ready-made problem, you will not know how to select a problem. Tomorrow, when you become guide, how do you select a problem? You don't know. You have not learned it. So that's why also learn how to select a problem, how to choose a problem. What can be a PhD problem? And that's why, please, always look for novelty. Every moment for the next 3, 4, 5 years, when you are doing PhD, you keep on asking this question, what is new in this? What is that enough? So this question you have to ask. Analysis is important to prove an idea, but idea is more important. See, one of the problems which I find, particularly in India, is this, that people are good at mathematics. This is a problem. You know what is the problem of being good at mathematics? You don't want to discover phenomenon. What you do, somebody has already discovered something, so you know good mathematics, you just keep on extending it a little bit and you get a degree, you get a couple of publications and so on. Please understand, Albert Einstein knew wonderful mathematics, but he is not known for that. He applied the mathematics. What he is celebrated for is his idea that time and space are correlated. They are not independent of each other, this idea. So actually what happens, an idea, whenever anybody proposes, the person who proposes the idea takes 80% of the credit. And the next 100% take the rest 15% and 5% remains. So the person, one or two people, they take 80% of the credit, and the next 100 people take 15% of the credit. So 15 by 100 is 0.15 is your credit. 0.15%. So this is what is the problem. We do not work on new ideas. People in the history of mankind have done such PhD work. One of them is Madame Curie. Madame Curie is from which country? Poland, yes. Originally from Poland, and she married Pierre Curie, who is French, and she worked mostly in in France. And Madame Curie submitted her PhD thesis. And 2 years later, on that, she got Nobel Prize. On the PhD thesis, somebody got Nobel Prize. This is possible. Max Planck got Nobel Prize for a derivation which is 2.5 pages. 2.5 pages. Professor S.N. Bose, an Indian, wrote a 4-page paper, sent it to Einstein. Einstein published it. And it became so much that 50% of all particles of this universe are named after him, bosons. So, my dear friends, it's the idea, the spark which is important. If somebody says that it is only, PhD is a hard work, definitely it's a hard work. But it's not hard work like a donkey. You have to sit down, you have to. My guide, I did a theoretical work with computer and pen and paper. My guide used to tell, my guide was just 4 or 5 years senior to me, Professor R.K. Sahu. He just retired in IIT Madras. He used to tell that for spending 1 hour at the computer terminal, you must be in your table with pen and pencil for 2 hours. So if you want to spend 3 hours at the computer center, before that you must have 6 hours of preparation. Because at the computer terminal, you look at the monitor, you don't think. To think, you need to sit down. So the idea is more important. And ideas will partially the literature will guide you. But at some point of time, doing a good literature survey is very good. But if you do too much of literature survey, there is a problem. You start thinking that these are the only ways. No. These are the ways people have done. These are not the only ways. There are so many ways to do it. So, I have written, hence, spend more time at your table than computer terminal or laboratory. This thinking process, looking at novelty, this is what is missing in most of the students. And that's why they come with very mediocre problems and mediocre solutions. They incidentally get a degree, but they don't get excitement of research. And then, what people try to do, there is a theoretical curve, you have done experiment, it's not matching, so you put your shoulder on the experimental curve and try to push it towards the theoretical curve. And somehow if it comes nearby, done, PhD is done. Don't try to do that. Don't try to do that. If there is a mismatch, try to explain the mismatch. Don't try to match. Because all theoretical things are done under certain assumptions. Who knows whether those assumptions are correct or not? Next, so why should we do experiments? Now I will talk about experiments and theoretical studies. Why should we do experiment? To know the truth. Because reality lies in experiments. To get insight into the physics, not just knowing the truth. Get insight. For example, if I put heat into a system, its temperature rises, not linearly, but this way. The next question is why? It can happen in certain systems. Okay? So, it can happen, and why it is happening? So, this why it is happening is physics behind the problem. And so, you must have insight into the physics to determine the unknown factors responsible. There are certain factors which nobody probably thought that this factor can also be useful, right? And so, find out those factors. To test a theory, suppose there is a theory, I want to find out whether the theory is correct or not. There are many people who have given theories for which there is no experimental proof, and that's why theory is not taken. Even Einstein's theory of relativity, years together, it was mathematically from every point of view perfect, but physics world didn't take. Till there was a solar eclipse in which it was found that solar ray is bending. Sun rays are not coming straight, it is bending, and from there near a planet, and so near a heavenly body, and so that near a heavy body the light bends. That was proven. That proved Einstein's. To even Stephen Hawking passed away. There is famous Hawking's radiation. He didn't get a Nobel Prize because that's not has been verified yet experimentally. In India, there is a wonderful person who can definitely get Nobel Prize, but he is not getting because it is not proven, and it will not be proven very soon also. Professor Ashok Sen, I don't know whether you have heard his name. He is in the Harish Chandra Institute of Allahabad. He does string theory in physics. So string theory talks about the lengths of 10 to the power minus 34 meters. So impossible to do experimentally today. We don't know about the future. And hence, also do experiments to facilitate simulation, modeling work. So, how do you need experiments to do theory? Because sometimes to do a theory, in the theory, you have certain constants. And it has got these constants, you must know them. For example, in turbulence modeling, you have 3-4 constants. And the constants come from experiments, different types of experiments. So there are many reasons why you do experiments. Now, planning. How do you plan your research? Defining aim, objective of the experiment, but remain flexible. What does it mean? you want to do this, I define that this is my aim. With this experiment, I want to do this, and this is the result I am looking for. But remain flexible. I mean, whatever you are trying, there is no certainty that that will come. Now, if it doesn't come, so what? Here, I would like to tell you a very interesting work, that if your experiment utterly fails, what happens? Even then, it can be interesting. And it happened to me. When I was in Germany, I was doing my postdoc. So, for 3 months, about 4 months, I built up an experimental setup. I was using nano suspensions, which is called nanofluids. And my conjecture was, because nano suspensions have got higher conductivity, so in boiling, conductivity plays a role. And so boiling will also be better. That was my conjecture. I had the experiment, and the day I did my experiment, I still remember, it was winter, it was snowing outside. Something else happened. My daughter was in 8th standard. She is now a doctor in an anesthetist in Cancer Institute. But that time she was 8th standard. I'm talking of year 2000, 22 years back. So she was going to school in Germany. So she came back one day jumping. Dad, I have seen microscope today. I said, what did you see? We have seen bacteria. I said, oh, wonderful. He said, they are going to show tomorrow metals. I said, metals? Okay, metals. We have also seen engineers. We have seen metals under microscope. So she asked me, what is there? Why do I see metal? What do I expect? I said, my dear, before doing an experiment, never expect anything. Go and see, find out. I have seen something. You may find out something different. So she said, okay. Now that day, I went and did my experiment after 4 months of preparation. And what I found, the curve, I expected that it will be improved. So the car should move to the left. I found the curve is moving to the right. That means by putting nanoparticle, boiling is becoming worse. Just opposite. I was perplexed. I did experiment 2-3 times. I said, and I was totally gone. Evening I came back. My wife gave me tea. I didn't know what I am drinking. So my daughter said, what happened, Dad? You were so disappointed. I said, no, I didn't get result. I didn't get result means? I said, I was preparing for this experiment. So I didn't get the result that I expected. So my daughter said, you told me last week, before doing experiment, you should not expect anything. And now you are saying that you got a result what you didn't expect. How is that? I said, whoa, this girl may be telling the truth to me. Next day I went back. I started doing experiment. I systematically find out under what condition it deteriorates. And then I found out why it deteriorates. Because the surface of the heater is micro level uneven. And the particles are nano level. And so particles go and plug those surfaces. And that unevenness of the heater is the place from where the bubbles, the boilings come out. And that is being plugged, that's why it's not happening. So I went back to the professor and said, see, our experiment failed, whatever I said. But I am at least happy that I have found out why it happens. Okay? So I said that and I was about to leave the room. Professor Wetzel called me and said, so, Dr. Das, when are you writing the paper? I said, what paper? He said, this one. I said, come on, this is a negative result. He said, don't forget, negative result is also a result. Write it. I was very reluctant. I said, who will take this negative result? The best of the journals. You write it, I will see. Very reluctantly, I wrote the paper. The paper is today cited 1,500 times. One of the best papers that I have written. So, my dear friends, please understand that, if you do not getting result can also be important. I can tell you another story. It happened in one of the laboratories in Calcutta. This cyclotron was there, and they were doing experiments. Now, electrons were accelerated and they are going. Now, electrons will go towards which pole? Positive pole, because electrons are negatively charged. They will go to the positive pole. One fellow came running, told his supervisor, "Sir, some 1 in 1,000, 10,000 electron is going towards the negative terminal." That fellow said, "Are you mad? Electron is negative charge. No, you are not doing experiment correctly." He said, "No, sir, I am saying systematically some are going like that." He shouted at that. He said, "Stop all those things, do your experiment correctly." So the fellow kept quiet. 1 year later, in one of the top journals, they declared that they have discovered positron. Positron is electron's mass, but it's positively charged. It moves towards negative terminal. And the person was shocked to see that in proof of that, the photograph that they put is exactly like what he got. Right? So it is the stupid supervisor who took away the credit because he didn't have that inquisitiveness. And that fellow, for discovery of positron, got a Nobel Prize. So this is what I'm trying to tell, that, even if your experiments fail, don't be disappointed. You can find out so many things from there also. Design, working out, the best possible design with all constraints you have got. Suppose, you don't have, today, I solved one problem, one of my students. We have to create a bright sheet. We don't have, one of the ways you buy a laser. It costs 5 lakhs. But I really don't need a laser. That kind of a brightness I can get from normal light we tried, it's getting diffused. So finally, what we did, No, you remember old time detectors? We brought a slide projector. Nobody has got slide projectors today. Somebody in Perambur has got it. We found out from the net. 5,000 rupees. We bought it and put it. Today I saw the result. Yesterday it was bought. Today we saw the results. Wonderful, it is coming. So quite often you need to be innovative to solve your problems. It's not that every time money is the constraint. There are small things by which you can solve your problem. Inputs from literatures and suggestions from technicians. Now this is very, very important. When you do the design of your experimental setup, be careful, think and talk to the technician. See, quite often what we do, what does he know? Technician is a IIT pass. Please don't forget, that fellow has done this job for 20 years, maybe 30 years. Many things he knows better than the professor. So give the benefit of that. I still remember one thing. In Germany, the technician was Mr. Herr Schutt. So one fellow was trying to measure the volume inside a tube. Now, inside a tube, why you have to measure volume? You can calculate. No, because the inside of the tube was not smooth. There was some pattern. So we don't know what the exact volume is. So what he did, this fellow closed with an aluminum sheet the whole tube. And then he told the Herr Schutt, a Chinese researcher, he said, "Sir, can you make a stand for me?" He said, "Why?" He said, "I will weigh, because this is a long tube, so I will weigh the tube in the weighing balance, big balance, and then one side is closed, I will put water into it, right? And then I want to weigh that one, and the difference is the amount of water which is gone in. I can find out what is the volume. So but you have to keep it vertical, otherwise water will fall. So make a stand for me so that on the weighing balance, I have to measure many tubes. So you make a stand so that I can keep the tube on that, which I can put there. Hershut looked at it and walked in the laboratory, and he said, why you have to do that? Do a simple thing. You take a bottle of water, you weigh the bottle, and then you put it inside, and then you weigh the bottle. The difference has gone there. That's it. You don't need to weigh the tube at all. You are to weigh only the bottle. Bottle with a tube, you just put it inside, right? Before putting inside, you weigh the bottle. After putting inside, you weigh the bottle. Whatever is the difference, that has gone inside. You don't need a stand. Who said that? Hershut. Who was not able to think that? A Ph.D. scholar. Hershut is, has got no degree, no university degrees. Please respect those people. They can do things which can be wonderful for each one of you. So in case of a new design, trial and error method is the only option, and sometimes it fails. I told you that one fellow who is now faculty member at IIT Madras, his experimental setup took 3 years. You know why? Just one heater fabrication. We tried 7 designs, 6 failed, and the 7th one was successful. It can happen. Yeah. That's why I said maintaining healthy relationship with the fabricator, respecting technicians, these are very, very important things. The next thing which you have to bother about, 2 things, accuracy and precision. Now these are the things you should learn. You are doing experiment. What do you mean by accuracy of an experiment? And what do you mean by precision of an experiment? Accuracy means nearby the correct answer, if you have any idea about the correct answer. In some cases you don't know what the correct answer is. Then it's very difficult to say. And precision means repeatability. Whenever you repeat an experiment, you get the answer within certain range, maybe 5%, 10%, depending on the type of experiment. Now you see, this is low accuracy and low precision, because this is the correct, the bullseye is the correct one and it's overall, and also they are not together. This one, this is low accuracy, still it is not nearby, but high precision, repeatable experiment, right? This is also called the bias. The other one is high accuracy and low precision. See, they are nearby the accurate answer, but each one is different. And this is the one which is high accuracy and high precision. So, while choosing the instrument, you must think of accuracy, precision, range. What range you require? Say, you want to measure frequency from megahertz or kilohertz or hertz or sub-hertz level. Response time, least count. Now this is what is very important, least counts. Or see, suppose you have a scale which has got millimeter graduation. With that, can you measure micrometer? No, you can't. See, if you do not have at least one order of magnitude lower, you don't have a board here, right? So if you don't have one order of magnitude lower, lower least count, you cannot measure. To measure millimeter accurately, actually you require a probe of micrometer accuracy. I mean, not 1 micrometer, maybe tens of micrometers. So this is what, you must have an idea with what I can measure. If you are trying to be more accurate than the instrument can measure, then you will be just wasting time. And of course, cost. Of course, cost. Suppose somebody says, I will give you very accurate, but it will cost, 10 lakhs of rupees. Now, you have to find out whether you have got 10 lakhs of rupees. Even if you have got, is it worth? Do I need that accurate or not? Next, calibration and error analysis. I won't go in details. Instrument calibration is a very important part of research. You know, the equipment, the company will send you calibrated. You must check it. Because they calibrate under one conditions. They can make mistakes even. When you are doing experiments, I will tell you it's not that very big company, that's why their calibration is correct. When I tried to measure thermal conductivity of suspensions by a probe called transient hot wire method, the best equipment available was nanotechnology. So we went to those labs and we took this thing, video footage. They took 2 hours of footage. They will edit only for 5 minutes. The fellow came and said, "Sir, God save IIT Madras." I said, "Why?" I said, "Why are you so late? You are not giving." I was chasing. He said, "Sir, come and see. I cannot find out 1 minute in which there is no violation of safety norms. Wherever I took video, everybody is violating safety norms. They have kept a cylinder next to a flame. They are, handling biological samples without gloves. They are handling lasers without goggles. What is this?" And one day, I was the dean, so we were giving this thing, advertisement for research scholars. So it was about to go for newspaper. The last draft I used to see, I found the same thing. They have given photographs of research at IIT Madras. A fellow, a girl was handling a laser without goggles. And another was handling biosamples without gloves. I said, "What to do?" And the fellow said, "It has to go today, otherwise it will not be published on Sunday, it has to go on Friday." So what to do then? The research secretary, one of the young research scholars, he said, "Sir, I will do it. Photoshopping." He put a gloves and put a goggles, and the thing was published. But this is, we saved the advertisement, but how to save the girl or boy? So this is what, fire extinguisher. How many of the research scholars know how to operate a fire extinguisher? When I went as a professor, visiting professor at MIT, Massachusetts Institute of Technology, they invited me. But what they said, on the first day, "Sir, before going to the lab, you have to take online courses on lab safety." 3 courses I had to take. Pass the examination, then only you get the permission to enter the laboratory, even if you are a professor. I was a visiting chair professor. Even then, for me, the rule is that. Please do not. People will laugh. Your friends will say, big scientist, putting coats, lab, doesn't matter. Let them laugh. Your life is important to you. So, that's what I am saying. I have given certain examples also. Now, analysis of experimental results. I have seen many of you put 3 points and draw a curve. How do you know the curve is like that? Because you remember school level geometry. With 3 points, you can draw a circle. 3 nonlinear points, if it is there, a circle can be drawn. So then I will ask, why not circle? Why are you giving it like that? So please understand, you must have enough data. Suppose in certain experiment you don't have enough data. What to do? Don't draw a curve. Just put the data like that. At least that's honest. You are honest. Consistency and repeatability, as I said, accuracy. This is another picture of the same thing, but a little funny picture. This fellow, has got an apple on the head. So this fellow is practicing to pierce the apple. If the apple pierces, No, the arrows pierces the apple. It is repeatable and accurate. If it goes everywhere, it is neither repeatable nor accurate. Or if it goes and hits the heart of the fellow, all of them, what is it? It's repeatable. Still it is repeatable, but not accurate, right? So, yes. See, this narrow boiling incident, I have already said, keen on observation of data. Sometimes some data, it's not useful. Process that one. How radioactivity was discovered. Henry Becquerel, he used to take pitch blende and put it in the sunlight, and they brought it and took photograph with that one. They thought it is the sunlight which is absorbed, which comes out as a radiation. One day, he forgot to put in the sunlight, and he kept one screen, X-ray screen, and a key and a pitch blende. Now you should have this curiosity. Next day, he came, he said, I forgot to do that. Suddenly he said, let me develop this X-ray. Now what do you expect in the X-ray? Nothing, because you have not put in sunlight. They put it in the developing room, and they found still the key has come. So it is not the sunlight. It is spontaneous emission of radiation, radioactivity. Then they did research. Becquerel, Pierre Curie, Madame Curie, three together got Nobel Prize for radioactivity. So this is one thing. And the other thing which is, see, you are trying to find out truth. Don't move your experimental points. Don't cheat, because you are cheating with yourself. You are cheating with science. And that's why honesty is the most important, this positron at Saha Institute, I told you. I mean, everything that you are seeing, try to analyze, but don't try to, I have a student who, if I say this result doesn't look nice, I think it will be like that. Next day he brings a car which looks like that. Now this fellow ultimately with great difficulty did his Ph.D. He came for, we two, myself and another professor, very reputed professor, we were guides. He came for recommendation for going as postdoc. We refused, because I don't have the confidence, not on his brilliance. Even if he is not brilliant, I would have given that. But his honesty. Because if this fellow goes somewhere in a top institute and does the same thing, then what people will say? That at IIT Madras, this kind of research is being done. So please don't do that. And mathematical modeling, I won't go to that much. It's not moving. Oh, that one? Okay. Okay. So sometimes when you do, people say theoretical is very, very difficult. You have to know a lot of mathematics, etc. No. You may have to know at certain point a good amount of mathematics, but what is needed for that particular problem? See, a very simple dimensional analysis which people do in undergraduate can be good enough. I'll give you an example. This is the atom bomb explosion in 6 milliseconds, 16 milliseconds, 53 milliseconds. But renowned British scientist G.I. Taylor, from dimensional analysis, he said what will be the effect of atom bomb, what will be the radius, what will be with, how the radius of the atom bomb will vary with time. When it was done, exactly it matched. It's from simple dimensional analysis. It's the idea which is important. Another one, this is the last story with which I would like to end, that when I went to MIT, I started working on biology. I'm a mechanical engineer, but I started working on biology, and the tumors were inserted into mice, and then with the help of a laser they were ablated. Now they could do it. They put gold nanorods inside the tumor so that it absorbs more heat. And they could do it, everybody was happy, champagne was opened and all that. I asked, because in that group there were biologists, there were mechanical engineers, there were chemists, synthetic material scientists and so on. I asked them that you are celebrating, but how do we know for a particular human being, if you want to use this therapy, how much of laser you have to give? How much of laser radiation for what kind of tumor, what size of tumor? What should be the exposure time? What should be the laser power? How do you find it out? I said, yes, we have to optimize, we have to do experiment. How many experiments? This is 400 experiments. 400 in vivo experiments, how much time it will take? 2.5 years. I said, why not? You simulate. He said, no, these simulations are very, very, complex. I said, let me try. I was in MIT. I came back. On my laptop, I started simulating. My wife was saying, you are like a research scholar, you are doing again this thing. I said, yes, I want to prove those fellows that it is not required. I did. These were the basic equations for modeling biological heat transfer. And then what we did, this is the grid. I got this kind of a result showing the temperature profiles, and then they did experiments and they found they are matching exactly. This is the thermal camera image of the same mouse. This is the mouse, and these are the tumors, right? And so, there are things where you can do your simulation in such a way, your engineering knowledge, you can use it even for cases like biology. And we did it successfully. After that, when I came back to IIT Madras, what happened? They were doing experiment, and they will inject the solution, and they will take CT scan and send it over net. I will sit here, my student will do computation, we will send the result and say that you change the power of the laser by this time this much, exposure time, and they will do experiment. These kinds of things. So these are various things of modeling. The last thing for doing research, you must have pride and modesty. Two conflicting things. Why pride? Because if you don't think, and that's why I said you choose your problem. If you don't think that I am doing a great work, you cannot do a great work. If you are thinking that somebody has done great work, I am only a tail to that one, then you can do nothing. Number one. See, it is great to think I am doing a great work, but many people do another mistake. They start thinking I am the only one who is doing great work. Now that is bad. Be modest. There are lots of people who are doing great work. In fact, when I was in IIT Madras before going to Ropert, every week I used to go to library and look at the latest journals. I used to go to the library like this, but I used to come out of the library like this, because it makes me modest to see the quality of work people are doing. I used to think, what am I doing? I am wasting time, I am doing nothing. Yes, you need to be modest. No, be relaxed and appreciate difficulties. Stay focused. Arjuna, that story that to Yudhishthir, Drona asked, what are you seeing? I am seeing my parents, my elders, my subjects and all that. Then you cannot. If you are seeing so many things, you cannot hit the bullseye. Arjuna was asked, what are you seeing? I am seeing not even the bird, only the eye of the bird. Second time was asked, What else you are seeing? Is I'm not seeing anything else. So you need to be like that. But at the same time, you need to be flexible as well. Be honest. You know, there are many stories. Because of paucity of time, I could not cover it. Enrico Fermi got a Nobel Prize and later on proved what he got Nobel Prize for is not correct. So somebody said, you know, you got Nobel Prize, now you are saying that's not correct. He said, so what I will do? If I find out that it's not correct, I will still close it because I got Nobel Prize. This is the spirit of a scientist. Okay? Always have the mental picture. In fact, to my students, you keep thinking that my experiment is running, this is happening, that is happening. I tell that even think of your experiment when you are in toilet taking shower. Even then you think about it. So avoid postponement and be honest. Be disciplined, sincere, punctual, but freedom and informality. As I said, don't waste time on being disciplined. You need to be disciplined. Interaction with your friends, learning from friends. Guide you will get, you know, in foreign countries you meet guide once in 3 months. Here at least you can meet guides weekly. But you can learn very little from the guide. You can learn more from your friends. A person who has done 2 years of research, a postdoc, you know, on the same area, somebody is working at IIT Madras, why don't you work? Nobody will stop you. Go to IIT Madras, talk to the student, find out, send a mail. There are so many ways to do it. Interaction with your friends without jealousy or envy. Be fully prepared for unforeseen problems. Requires few months to few years for preparation to great results in no time. Right? And so, if you put all this, what do you think? It is the journey or the effort that is true satisfaction. The happiness of research. Because a simple thing. I am not beating my drum, but tell me why I am doing research today. I have got position. I have become IIT professor. I have become IIT dean. I have become IIT director. I have become chair professor of MIT. Why do I do research? What to get? To get the pleasure of finding out things. That is supreme. All these are incidental. I would say not of much consequence. The most important consequence is when I look at something, oh, this is something which my student has done. This is something what I have done, I have found out. That pleasure, nobody can take away from you. For the next couple of years, enjoy that pleasure and come out with great colors. Thank you very much. Stupid questions. There are only stupid answers. Are there questions?
I think they are a little overwhelmed after all the truths that you have exposed about PhD and research. So participants, if there are any questions, this is the right time to ask.
You know, I was most frustrated last 1 year because I came back from here and lockdown, I cannot go to lab, I cannot talk to my students. This is pathetic. And you know, somebody asked me that, now how are you feeling? I said, oh, I feel that, you know, I was not able to breathe. Now, you know, a stream of fresh air has come. I can come, I can talk to my students, I can find out what they are getting, what they are not getting, where they are getting stuck, and so on. And I can think of doing something new. And another thing, read. I think the previous lecture was on reading. You know, in last 1 year, what I read many things. Not just on research, but on research itself, I read about quantum mechanics. That is not related to my area. I study, you know, listen to 31 lectures which Professor V. Balakrishnan has given in net, 31 of them. I read a book on quantum mechanics. I am now reading a book on quantum computing. Now, shall I work on quantum computing in future? I don't know. I may not. I may. I read that. I read Yuval Noah Harari's, Sapiens. Last week I bought The Life of Rajaraja Chola. My dear friends, if you do not have interest in finding out how human society, how this world, how this universe developed, I think you cannot have the excitement of research. So to start with, to all of you, I would ask you, start with that one small book. Surely you are joking, Mr. Feynman. Please buy that book. It is available in Amazon, and read that book. I think that is the perfect beginning of a research career. Thank you very much.
Thank you, sir. That was a brilliant lecture that you have given us, touching various points about research and PhD. And the moment you started giving those examples, the difference between a Chennai auto driver and Michael Schumacher, I surely understood where this was going. And the curves, the reproducibility and the accuracy graph that you showed us, I think it is very relevant to every discipline of research. Right. Because here, this is a mixed group. We also have a student from humanities. We have somebody from mathematics, physics, management. Almost all the groups are here, but it was very relevant, and I'm sure that our students would bear all this in mind. And because this is the beginning of their research, I think they are a little, frizzled with all the information that they have got now, but they'll surely take it forward. Thank you for accepting our invitation and being here with us this evening. Thanks a lot,
It's
sir.
my pleasure. It's my pleasure. Thank you very much.